Water for recycling comes from our sewer and wastewater systems. By law, California requires this water to be treated at a sanitation facility before it can be discharged into the ocean or sent back into streams. So it comes to the recycle operation with a certain degree of disinfection already done. All wastewater goes through a sanitary treatment process. For recycling, it may be sent to a sanitation facility like this one, specifically designed to clean it to a high enough standard for various uses. This is the West Basin Water Recycling Plant in Los Angeles. The cleanup starts with something called flocculation, which is a process to separate the solids from the liquids. The solids are sent on to drying stations and sometimes used in ag operations to enrich soil.
Start with a secondary effluent from the Hyperion pump station plant. Comes into the plant. The mixer is where we add chemicals to enhance our flocculation. What flocculation is doing is trying to get the particles to come together and form. They're very small particles. We want them to become larger particles because it's easier for the filtration process to remove those particles. So it goes through this serpentine flocculation type process. Direct filtration, where the water comes in and you've got a multimedia sand type of filtration material. The water goes through that, comes out the bottom.
The liquid is treated with chlorine so that it's disinfected. We call this tertiary treatment and allow this water to be used for landscaping and some industrial applications.
So we add sodium hypochlorite here at the plant, and at that point it's ready for storage and distribution into our system.
If it's then further purified by a system of microfiltration, it may be high enough quality for other industrial uses. These straw-like filters produce clean water ready for the next step. That next step is reverse osmosis.
This is the reverse osmosis membrane vessel. It comes in these long plastic tubes, but basically this is a wrapped membrane, a sheet that's been wrapped up around itself to save space. The water will pass through this membrane much like it would pass through the cell wall of a single cell. That's why we call it osmosis, but it's reverse osmosis since it's passing through the cell the other way. Water's coming into the vessels through the middle at high pressures. Once inside the vessels, it passes through the membrane, which is basically a sheet, taking out the dissolved materials as well as definitely the pathogens and any remaining organics. Once it goes through those membranes, large pressure drop, it comes out the side, and then all of the membranes, all of the vessels are all collected into a single header, and then they go off for distribution. The one issue with this particular treatment process is the high energy costs, but with the advances in technology, those costs are coming down. They're becoming more efficient and less power intensive.